This is the second video for our 3.1 notes. This video focuses on example 2 and on finding extrema on closed intervals. So here are our guidelines for finding extrema, and when we say extrema we mean absolute mins and maxes and relative mins and maxes. First, find the critical numbers of function f on the interval a to b. So let's take a look at example 2a. Find the absolute extrema of this function f on the interval -1, 2. Use your calculator to sketch the graph and verify it. We're going to do that last. First, we're going to think about finding the extrema. We said the extrema exist at critical numbers. In order to find the critical number, we need to take the derivative. Okay. So I'm going to find f prime of x here in example 2a. I have 4 times 3x to the third minus 3 times 4x squared. So 12x to the third minus 12x squared. Okay, in order to find the critical points, I need, or critical numbers, I need f prime of x to equal 0 or be undefined. Looking at this derivative here, there isn't any value that's going to make 12x to the third minus 12x squared undefined. So I'm going to have to focus on f prime of x being 0. So let's set f prime of x equal to 0. Alright, in order to solve this and figure out where our critical numbers are, I'm going to have to factor. So I'm going to factor out a 12x squared, and I'm left with x minus 1. Okay, so this is actually, I'm running out of space here on this page, so I'm going to move up here. Set each factor equal to 0, and here, when we divide by 12, we get 0 equals x squared. So x must be 0. Over here, 0 equals x minus 1, so 1 equals x. So our critical numbers are at 1 and 0. Okay. I'm going to clear the page so that we have room to keep working on this. Okay. So we just found that our critical numbers, critical numbers were x equals 0 and x equals 1. So we want to evaluate f at each critical number. The easiest way to do this might actually be a table. So I'm going to create a table with x and f of x. I'm going to leave a little space in the top for something that we're going to do in a minute, but I'm going to find f of x when x is 0 and when f of x is 1. So if I plug 0 into my original equation, I have 3 times 0 to the fourth minus 4 times 0 to the third. So 0 minus 0 is 0. Plug 1 into this equation, I get 3 times 1 to the fourth, which is 1, minus 4 times 1. That gives me, and these are multiplication symbols, maybe I should use parentheses. Okay, that gives me 3 minus 4, which is -1. Alright, I'm going to clean this up and just put -1. Alright, so we evaluated f at each critical number. We also want to evaluate f at each endpoint. So our endpoints are -1 and 2. So I'm going to put -1, which is an endpoint in, and we're also going to look at it at 2. If I plug -1 in here, I have 3 times -1 to the fourth minus 4 times -1 to the third. That gives me 3 times 1, which is 3, minus 4 times -1. That makes this 3 plus 4, which is 7. Okay, so I'm going to erase all of this again and just fill in 7. Alright, for 2, we have 3 times 2 to the fourth minus 4 times 2 to the third. just trust me on this one, it comes out to be 16. Okay, so I'm going to clean this up. We have 16. Okay. Step 4, the least of these values is the minimum, the greatest is the maximum. So looking at these f of x values here, this is our minimum. And our maximum is 16. Okay. Now, this maximum here at 2 can be an absolute max because it's an endpoint, but it can't be a relative max. The one at x equals 1, the minimum, is a relative minimum, but it is also an absolute minimum. It can be both. Absolutes can be inside the function, or they can be on an endpoint. Okay, so grab your graphing calculator. We're going to plug in f of x and graph it. All right. Now, your graph will give you a complete graph. We just want the graph from -1 to 2. If I graph at -1, there'll be a point at 7. Then we have 0, 0. We have 1, -1. And the final point is at 2, 16. It's pretty high. I didn't draw this very well to scale. Let's put 16 here. So the graph looks something like this. All right, on your calculator, like I said, it's going to keep going, but we just want to look at it on this interval. Okay, so we can see here, this is an absolute and a relative min. The absolute max is here at 2. Okay, so you can find all of these values in the table by hand, or you can use your calculator to find them. You should be comfortable doing both. Let's move on to the next example. So this is example 2, part B. Find the extrema of f of x equals 2x minus 3x to the 2/3 on the interval -1, 3. So, finding the extrema, again, first that means find f prime of x and look for critical points. Okay, so f prime of x in this case, well, the derivative of 2x is just 2. The derivative of the next part, we have the -3, bring down the 2/3, x, and when I subtract 1 from 2/3, I get -1/3. So that's our derivative. Let's simplify it. We get 2, 3's cancel, minus 2x to the -1/3. Okay, so we want to think about where is this derivative equal to 0. So remember, we're finding the derivative and determining critical numbers. Okay, so we want to set this equal to 0. Okay, I can move 2 over. I have -2. Actually, let me move the variable expression over. So I get 2x to the -1/3 equals 2. Divide both sides by 2. X to the -1/3 equals 1. Excuse me. This really means 1 over x to the 1/3, and we know x to the 1/3 is really the cube root of x. We want this to be equal to 1. Multiply both sides by this cube root. We get 1 equals the cube root of x. So x has to be 1. So x equals 1 is a critical point. But remember, the derivative being equal to 0 is not the only time we have critical numbers. We also have a critical number if the derivative is undefined. So I want to think about when would my derivative, let me put it here, when would f of x be undefined? Well, going back to what our derivative is, f prime of x equals 2 minus 2x to the -1/3. We can also write that with the cube root. Okay, now it's easier to see when this might be undefined. it's going to be undefined when this denominator is 0. So if I set the cube root of x equal to 0, I get x equals 0. This is also a critical point because my derivative will be undefined. I can't divide by 0. Okay, so my two critical points, x equals 0 and x equals 1. Let's clear the page so we can keep working. All right, so I'm going to rewrite critical points here, or critical numbers, x equals 0 and x equals 1. Okay, let's make a table because next we're going to start evaluating. We know in that table we need our endpoints, so I need -1. I need my critical values, 0 and 1, and I want my other endpoint, 3. Okay, again, you can figure these values out by hand, or you can plug f of x into the calculator and use the table values. You should be comfortable doing both. I'm going to give us the values for the sake of time. So if x is -1 and I plug -1 into f of x, I get -5. If I plug 0 in, I get 0. If I plug 1 in, I get -1. And if I plug 3 in, I get 6 minus 3 times the cube root of 9, which is approximately -0.24. Okay, if I'm looking for mins and maxes, this is the absolute max, the absolute min, because it's the lowest number. It can't be a relative min because it's at an endpoint. Next, I want to look for the maximum. Well, the greatest number here is 0. This is a absolute and a relative max. Okay, let's plug it in and see what it looks like when we plug it into our calculator. 1, 2, 3. 1, 2, 3, 4, 5. Okay, so our graph looks like a point here at -1, -5, one at 0, 0, one at -1, and one that's at that -0.24. So our graph looks like, oops, that should be a relatively straight line, and then a curve. Okay, so this matches. This should be our absolute min, and this is the absolute and relative max. Okay, when it says find the extrema, I actually should have mentioned this before. We want to give our final answers as maxes and mins. So our max here is at -1, 5. That's your final answer. And the min is at 0. Oops, I messed it up. The maximum is at 0, 0. And the minimum is at -1, -5. So those would actually be our final answers. This maximum and this minimum. Those are the extrema. That also means for A, I didn't quite give it in the correct format. In A, our min, so this is for problem A, should be at 1, -1, and the max is at 2, 16. We're actually not going to do example C, the next one, because it requires use of a double angle formula, which you haven't learned yet. So just put example C on hold for now, and we'll go over it in class. But you've seen enough that you should be able to complete the homework at this point. All right, see you tomorrow.